Question 11. Start by substituting in 4, which gives you 60, then 3, which gives you 24. State the result as too big or too small. Go to halfway between. That result is also too small. So try between 3.5 and 4. Try 3.7. That was too big. So drop down to 3.6. That was too small. Remember to go halfway in between to prove which one is the best. So I went to 3.65 and that was too small. Produce a number line to show the results. Here we've got 3.7, which is too big, 3.6, which is too small, and 3.65, which is too big, which means the best answer is hit somewhere in here. Wherever it is, when you round it off to one decimal place, you will get 3.6. So the best answer is 3.6 to one decimal place. Question 12. Write down the volume for a cylinder and change 3/4 of a litre into centimetres cubed. The volume of a cylinder is the area of the base, which is a circle, pi r squared times h, and 3/4 of a litre is 750 centimetres cubed. Bring them together to create a formula. Substitute in r, which will be half the diameter, which is 8.5, and then solve for h. So 750 is equal to pi times 8.5 squared times h. Rearranging gives you 750 divided by pi times 8.5 squared, which gives you h equals 3.304254.874 centimetres. Running to a sensible level of accuracy, we're going to go to one decimal place, 3.3 centimetres to 1 dp. If you've gone to 2 decimal places, it's 3.30. 3 decimal places, 3.304, but anything more than that is a level of accuracy beyond this question. Question 13. Add the information onto the diagram that DC is 7 and the angle ADB is 40, and then you've got to try and work out the length of AD, which is this long side here. So you need to get some more information into this triangle. In a parallelogram, that these two sides will be the same length, so that means that is 7. Now you've got these two, you can find this side. It's a right angle triangle, so you can use trigonometry. Write down SOH, CAH, TOA, and think about what you've got. Well, you've got the side opposite the angle you're working with, and you're looking for the hypotenuse, so it's going to be sin. Write down the information. The sin of 40 equals 7 over the side you're looking for, which is AD. Rearrange to make AD the subject means that AD equals 7 divided by the sin of 40. And a calculator will give you that answer. Look at the question, add round to 2 decimal places. So AD equals 10.89 centimetres. Question 14, got to make m the subject. It's split, so bring it together on one side. 6m squared, take away m squared equals k. Oh, well, that simplifies to 5m squared equals k. Get m squared on its own, divide both sides by 5. And then you want m, not m squared, so you square root both sides. That gives you m equals the square root of k over 5. Question 15, the value of r. Well, r is the interest rate, and that's in here. The 1 at the front just keeps the principal value of 800, so the interest rate is this bit here. Change that into a percentage, will give you 3.5%. The value of the investment after 7 years, put a 7 in the formula, work it out using a calculator and the power button, and then remember this is money, so always round to 2 decimal places. £1,017.82. Standard form is going to be 1.66 times by 10 to the power of 3, 6, 9, 12, 15, 16, 17. And then this one, it says give your answer as an ordinary number, so you can just put it into the calculator, and if it doesn't give you an ordinary number, then change it from standard form. 3.7 to the power of 7 multiplied by 5.3 times 10 to the power of negative 2 equals, and it gave me as an ordinary number, so no problem there. 1961000. 1,961,000. Question 17 looks like tolerance because of the words minimum value, and you need to use density. Density equals mass over volume. So work out the tolerances of 340 grams, the nearest 10 grams. So tolerance is 10, divided that by 2 is 5, so that gives you 340. Right. So 340 with a tolerance of nearest 10 grams. Is take 10 divided by 2 is 5, so that's 345 and 335. And then 295 to the nearest centimetre cubed is the nearest 1, so half that's 0.5, so it's 2.95, 295 at the top, 294 on the bottom. Density equals mass over volume, or if you learned it in science, use the triangle. You've got to work out the minimum value for the density. So you want the lowest possible value for this. So you want the biggest number here on the bottom and the smallest number there on the top. So that's going to be 335 at the top and 295.5 on the bottom. Working that out gives you 1.133671743. Rounding to 2 decimal places gives you 1.13. Don't forget the units, it's grams per centimetre cubed because you're doing the mass divided by the volume. So that's the mass units, that's the volume units, and the line means divide. Question 18 is a typical formula question. We're going to make n equal to 30 nails in a packet, so that's going to be 30p plus 100 nails in a box. That's it. Question 19 is about column vectors. You've got to go from P to Q, so plot P, plot Q, and then write down the vector of P to Q. So you count across 1, 2, 3, 4, 5. That's your top number, and 1, 2, 3, 4, 5, 6, 7. And there's your column vector there. The second part, you've got to go from Q to R, 3 along and 3 down. So add that onto your diagram. 1, 2, 3 along, 1, 2, 3 down, so that's R. Add the midpoints to your diagram, halfway along each line, just by counting the squares and halving it. Then you've got to work out the vector to get from M to N. So that's here, so go across 1, 2, 3, that's 4 squares across, and 1, 2 squares up, so it's 4, 2. Even though you're working from the halves, it's still 4, 2. Question 20. Add the information onto the triangle about the angle and the sides, and then the area of the triangle, because it's not right angled, will be a half AB sine C. If you forget the formula, look in the front page of your exam booklet, then substitute in the values for AB and C, work it out on a calculator, and then check the question. It says correct to 3 significant figures, so you round off to the first 3 numbers, 6, 5, and this will round to a 3, so it's 65.3 to 3 significant figures. Don't forget the units. Using the cosine formula, again in the front of your booklet, you need to identify the 2 sides and the angle between them and substitute them into the formula. That will give you a squared and then square root to find the size of a. It should look something like this. Now work it out and you'll get a and round to 3 significant figures again. A squared is 153.7848666, so A is 12.4 centimetres, rounded to 3 significant figures. Question 21 is about similar triangles, that means they're enlargements of each other. So you're looking for the scale factor enlargement to get from x minus 1 to 2 brackets x squared minus 1. The key here is to know that that is the difference of 2 squares and work from there. So rewriting it as 2x plus 1 x minus 1 by factorising it, you could see that the scale factor enlargement, the bit that's different between the two, is the 2 and the x plus 1. So the scale factor is 2x plus 1. So the area factor will be this squared. So we expand this first, which gives 2x plus 2, and then do 2x plus 2 all squared, which gives you 4x squared plus 8x plus 4. So that's the area factor. Now you're told the area of the smaller triangle is 3, and so you've got to work out the area of the larger triangle, so you take 3 multiply it by your area factor, which is 4x squared plus 8x plus 4. Bracket around all of it, and you get 3 4s are 12x squared, 3 8s are 24x, and 3 4s are 12, which is what you had to show, was that the t, which is the area of the new large shape, was this. That's it. Question 22. Simultaneous equations that have got squares in them involve substitution. Here, substitute y for x plus 1. So this just becomes x plus 1 all squared. So you've got x squared plus x plus 1 all squared is equal to 16. Now you've only got one letter, so you've got to expand, collect like terms and solve. X squared plus 2x plus 1 equals 16. That gives you 2x squared plus 2x, taking away 16 minus 15 equals 0. Now you're thinking about two brackets for this. If two brackets don't work, you've got to use the formula which is in the front of the formula booklet, which is